Good day, viewers all over the world. You are welcome to Friday online class. So today we want to talk about complex number. That is introduction to complex number. Complex number. So we know that there are six. We have introduced six set of numbers, starting from the natural numbers. We have the natural numbers, which is the first set of numbers. We have the first set of numbers. We have the natural numbers. These are positive counting numbers. We have the integers. We have integers. This consists of positive, 0, and negative whole numbers. We have the rational numbers. Numbers that can be expressed in form of A over B. That is, you can express a number as fraction where B must not be equal to 0. That is rational numbers. We have irrational numbers. We have the real numbers. These are the 5 set of numbers that most of us are familiar with. These are the 5 set of numbers that most of us are familiar with. So today we want to introduce complex numbers. So what do we understand by complex number? Of course, complex number is the higher form of the real numbers. That is, if you have a number, let's say x, that can be expressed as a plus ib. That is, if you can express a number in this form, then such a number is referred to as complex number, where a is the real part. This is the real part. Then where b is called the imaginary parts. Imaginary parts. So in case of complex number, it's of two forms. We have the real parts and we have the imaginary parts. So let's take notes. In case of a complex number, we have the real parts. Real part is when we have a constant. Then where we have this I, it's actually indicating that this is the imaginary part. So we should take notes that B is the imaginary part. Not only that, we should note that this I, we must know the implication of this I. I is given as square root of -1. This is the value of I under complex number. Please take notes. This is the value of I, which is the imaginary part. Then I squared, if I is equal to square root of -1, if I squared I here, I squared is equal to -1. Please, I want us to take notes of this value. It is very important. Okay, why do we have the concept of complex number? The complex of complex number, this complex number is actually important in a situation whereby the problem has gotten beyond the real concept. For instance, if you are asked to find the square root of 4, -4, let's say we are asked to find the square root of -4, square root of -4. If you press your calculator, we are going to get error here because we cannot find the square root of -4 directly, because this problem is actually in the complex form. But the only thing that we can do here is that we can actually we can split this into 2. That is to say, square root of -1 times 4. Of course, -1 times 4 is 4. So we are on the safer side. Then this same thing as square root of -1 times square root of 4. What is square root of 4? That is 2. Then from our knowledge of complex number, square root of -1 is equal to high. So the value will be 2 high. So we can only get the solution to square root of -4 in the complex sense. We can only get the solution in the complex sense. So we can only get the solution in the complex sense. So please let's take notes that why do we need the concept of complex number? When we have problems or when we have issues that cannot be resolved in the real sense. You know that real number, you cannot get this value. It's not possible. All the set of numbers that you have done in the past, natural, integers, rational, irrational, and real, you can never find something like this. So this is the reason why we the concept of complex number is important. The complex number is important. Not only that, like every other numbers that we have, we can actually carry out basic operation on complex number. We can carry out basic operation on complex number. For instance, we said I is equal to square root of -1. I is equal to square root of -1. That's what we said. That I is equal to square root of -1. So if I is equal to square root of -1 and I squared is equal to -1, you can be asked to evaluate when we have multiple choice question, objective question. You can be asked to evaluate I raised to power 9. The question can say evaluate I raised to power 9. So what do we do here if you have this type of problem? So what do we do here? If you have to evaluate, you should find value of I raised to power 9. Of course, you can break this down. I raised to power 9. If I squared is equal to -1, I raised to power 4, I raised to power 4 will be equal to 1 because I squared times I squared will be I raised to power 4. It will be equal to 1. So we can break this down to say this is I raised to power 4 indices times I raised to power 4 times I. Now this I raised to power 1. In the law of indices, these bases are equal and the operating sign is multiplication. Just add all the power together. So we can break I raised to power 9 down. It will be equal to I raised to power 4 times I raised to power 4 times I. Of course, I squared is equal to -1. I raised to power 4 will be equal to 1 because -1 times -1 is 1. So this will give us 1 times I. At the end of the day, the value will be high. Please, let's take notes. If you have multiple choice questions, you have to find the value of I raised to power 9. And of course, I raised to power 9, if at the end of the day, it's going to give us I. So please, let's take notes. We can be asked this type of problem when we have objective question, multiple choice question. Okay, so let's take notes. It is important to take note of this type of question. Okay, so we can have this type of problem under multiple choice question. So it is possible. Not only that, we can be asked to find I raised to power 6. So what if you have to evaluate I raised to power 6? What would this give us? Of course, law of indices, we can break it down to 2. We say I raised to power 4 times I raised to power 2. 4 plus 2 is 6, so we can have something of this nature. Okay? Then at the end of the day, I raised to power 4 is 1 because I squared is -1. So 1 times -1 will be equal to -1. So the value of I raised to power 6 is -1. The value of I raised to power 6 is -1. So please, let's take notes. Let's take notes. Okay? So let's introduce basic operation on complex number. That is addition, subtraction, multiplication, and division can actually be carried out under complex number. So let's introduce basic operation on complex number. Basic operation. So let's start with addition. Addition. Let's start with addition and subtraction. Let's start with addition and subtraction of complex number. So let's start with addition and subtraction of complex number. Addition and subtraction of complex number. So how do we add or subtract two complex number? How do we add or subtract two complex number? Okay, how do we add or subtract two complex number? I will start by giving an example. Let's say example. Let's start by giving an example. Let's say the question says that you should simplify 4 plus 5x then plus 7 minus 2i. Okay, this is a particular example under addition of complex number. So what do we do here? If you have to add two complex number, what do we do here? The only thing that we can do here is that we are going to add real parts to real parts, then imaginary to imaginary. That is, this is what I'm saying. 4 plus 5i plus 7 minus 2i. Please, let's look at it very well. This same thing I'm saying 4 plus, this is the real part of this complex number. Whenever we have I, it's talking about imaginary parts. So 4 plus 7, that's what we are going to get here. Plus, these are the imaginary value. The one with I is talking about the imaginary value. We have 5i plus times minus is minus 2i. At the end of the day, we are going to have 4 plus 7 is 11. 5 minus 2 is 3. So we have 5 plus 3i as the final answer. So when we had two complex numbers together, this is what we are going to get. When we had two complex numbers together, that is what we are going to get. So please, let's take note. Okay? We are trying to perform basic operations on complex number. So this is the first example on addition. So let's take another example on subtraction. That is when we subtract two or more complex number from each other. So what are we going to get? So that is the second question. Then let's say we have 3 plus 6i minus 6 minus 8i. So in this case now, this example 2 is under subtraction. So how do we subtract excuse me, two complex number? Okay, we have 3 plus 6i minus 6 minus 8i. Read to read, then complex to complex. That's what we are going to have. Read to read, complex to complex. So we are going to have 3 minus 6. This is read to read, then complex to complex. Plus 6i. Here it's minus times minus. It will be plus 8i. At the end of the day, we are going to have minus 3 plus 14i as our final answer. So we are going to have minus 3 plus 14i as our final answer. So please, let's take notes. Let's take notes. Okay. So what if we are given this problem? No. What if we are given another question? Let's call that example 3, where we have to find 6 plus 5i minus 4 plus 3i. 4 minus 3i, okay, plus 2 minus 7i. So if you have to solve this, what are we going to get? Please look at the example 3 on the board. What are we going to get here if you have to solve this? Then if you have to solve this, we carry out the normal arrangement. That is, we say that we had the real to real and complex to complex. That is, here we have 6 plus 5i minus here we control everything in this bracket. That will be minus 4, minus times minus plus 3i. Then we have plus 2 minus 7i. So let's arrange real to real and complex to complex. We have 6 minus 4 plus 2. Then we have plus 5i plus 3i minus 7i. 6 minus 4. Of course, 6 plus 2 is 8. 8 minus 4 is 4. So we have 4. 5 plus 3, 8 minus 7, that's 1. Then we have minus I. That is what we are going to get. That's what we are going to get at the end of the day. So please, let's take notes. So we are going to have, no, this is plus, because 8i minus 7i is plus I. So that's what we are going to get. So please take notes. So we have been able to introduce addition and subtraction of complex number. So I want us to introduce one more basic operation, that is, let's say, multiplication. Let me introduce of once I introduce of complex number, then I can actually close the class. We continue from there some other time. So let me introduce multiplication. Multiplication of complex number. So let's introduce multiplication of complex number. You know, in case of addition and subtraction of complex number, it's very simple and straightforward. So that is very simple and straightforward. So let's introduce multiplication of complex number. If we have two complex number, how do we multiply two or more complex number? That's what we're about to do here. So if you have two or more complex numbers, say A plus BI, this one complex number, multiplied by say C plus DI, this is another complex number. What do we do here? How do we multiply this? Of course, we are going to expand. We open up. We expand what we have here. A will multiply everything here. Then BI will also multiply everything here. So we have AC plus ADI, then plus BCI, then plus BDI squared, because I times I will be I squared. So we have AC plus this one has I, this one has I. You can combine the two into brackets AD plus BC, everything into brackets I. But we recall that I squared is equal to minus 1 from the onset, because I is equal to the square root of minus 1. When we take the square root of both sides, I squared becomes minus 1. So I squared here, we change everything here, this plus to minus. So we have minus BG. At the end of the day, the expansion of these two complex numbers will now be AC minus BG plus into brackets AG plus BC I. That's what we are going to get. So when you multiply two or more complex number, we have to be careful. We must be careful of the value of I, because the value of I actually has implication, as we have seen on the board. So let's consider two. Let's consider two examples under multiplication of complex number. Let's consider two examples under multiplication of complex number. The first one, where we are asked to simplify. We have to simplify 4. We have to simplify 5 minus 4i into bracket 5 plus 4i. That's what we have. This is what we are asked to solve. So how do we solve this? Excuse me. I want us to concentrate. How do we solve this? Of course, we are going to open up. We have 5 minus 4i into bracket 5 plus 4i. That's what we are given. So that's what we are given. How do we solve this? 5 will multiply this 2, then 4i will multiply this. So we have 5 times 5, 25, plus 5 times 4, that's 20i, minus 5 times 4, minus 20i. This will be minus 4. 4 times 4 is 16. I times I is I squared. So that's what we're going to get. 20 I can actually take care of 20i here. 20i minus 20i. At the end of the day, we have 25 minus I squared by formula is equal to minus 1. So if we have minus 1 here, minus times minus here will be plus. We have plus 16. Then at the end of the day, we realize that our answer will be 41. Look at this is 5 minus 4i. Then this is 5 plus 4i. This is a conjugate of this. If you can recall, under sort, when we talk about conjugate of a sort. So when you use a sort to multiply its conjugate, automatically we are going to have a whole number. So also, in case of complex number, when you use a complex number to multiply its conjugate, we are going to have a real number. So let's take notes. So this is example. This is the first example. Then let's take one more example under multiplication. Then we continue from there in our next class. So let's take another example. Here we are given, we have to simplify 4 minus 3i all squared. This is what we are given. 4 minus 3i all squared. So, or we can say 4 minus 6i minus 6i, 4 minus 6i all squared. So what do we do here? We just open up, we expand, do the normal thing, then we open up. So here, if you have this, we say this is the same thing as this is the same thing as 4 minus 6i multiplied by 4 minus 6i. That's what we are going to get. So 4 multiply this 2, this minus 6i will multiply the 2. 4 times 4 is 16. Minus 4 times 6, that's 24. Minus 24i 6 times 4, that's minus 24i. Minus times minus is plus. The 6 times 6 is 36. That's 36i squared. So here we are going to have 16 minus 24 minus 24, that's minus 48i. Then I squared is equal to minus 1. So here we are going to have minus times plus will be minus. So we are going to have minus 36 here. 16 minus 36, that's minus 20. So invariably we are going to have minus 20 minus 48i as the final answer. So let me just read the recap of what we have discussed today. Then we continue from there in the next class. I was able to introduce complex number, and I said that complex number are number that consists of two parts, the real and the imaginary part, as we have it on the board. Where we have the constant is called the real part, and where we have this I is just talking about imaginary part. This simply means that this value of B here is the imaginary part, while A is the real part. So we give the value of I to be equal to square root of minus 1, so that I squared will be equal to minus 1. Then we go straight into the basic operation on complex number. So we're able to give example on addition and subtraction before we now move to multiplication of complex number. So I would love to stop the class here. By the grace of God, we are finishing there in the next class. Thank you.